Hi, Zach McKinney here with Team 16. Looks like we've made it to the end of EEE 488, fall semester 2018. Everyone's busy calculating what grades they need on their final exams to pass their courses, but Team 16 is actually looking forward to getting some dedicated time over the winter break to work on a project and get it all finished up. Just a reminder, we're building a device for the DIY community where one can install two CTs on the main service entry conductors of a home, analyze that current signal via microcontroller, and identify using two sensors how many appliances are running, not running in a home, and how much power each appliance is using. So two sensors to measure multiple devices, kind of measurement by inference there. It's kind of exciting to us. I'm going to talk to you about the schedule. Brandon Ward is going to talk to you about our facilities and analyzing our current signal in the time domain. Keith Snyder is going to talk to you about converting that signal to the frequency domain with a fast Fourier transform and analyzing those individual signal components to determine which appliance is running. And Eric Bentley is going to talk to you about the UI and how a user can interface with our device and what we're going to do there, and of course our budget. Like I said, we're going to work on this over the Christmas break. We're going to get the UI finished up, and then in January when we get back to class, we'll finish putting the bow on our prototype and have a product that's ready to go to the DIY community. Our focus in the spring is going to be actually putting together the how-to files, the README files, developing articles for Instructables.com, uploading code to GitHub.com, publishing our code, example code, README files, and really putting together a nice package for the DIY community online to be able to do what we've done and take what we've learned and developed and apply it themselves at their homes, so that anybody that wants to can monitor how much power their appliances are using. We've built in a little bit of flexibility in our schedule towards the end of March, beginning of May. We want to be able to go into a run maintain mode sometime in that time. Once we get the article published, we're looking forward to maybe getting some good feedback, developing an FAQ or something like that. And if we get some good ideas from the online community, maybe we can come up with a version 2.0. Key to our schedule is April 26th, when we're going to be doing our final presentation. And of course, as of today, 159 days from now, May the 6th, we're going to graduate. So with that, I'm going to turn it over to Brandon.
Thank you, Zach. I'm Brandon. I'm going to go over the facilities and time domain portion of our project. Here we've got the cables coming in, and that's where we've got our CTs wrapped around. So we had a hard time with that because the CTs are so small and the cable is so big. We got 3/0 cable here. Comes into our main breaker and then gets distributed into all these branch circuits. Most of the time you're going to see power meters that will go on each individual branch circuit and display what is going on all those and add it up and display how much power you're using. So what we're proposing is that we would have only two CTs, which would significantly lower the cost with the hardware. So you bring it over, comes into a shorting block. We've got this set up so that we can safely work on the CT circuits on the back end over here, where we're running a voltage divider on it so that we can increase the voltage and have it in a positive voltage domain so that we can record it on the photon. Photon won't go negative. But before it goes in there, it comes through these two meters, which displays instantaneously what's going on and how much power we're using. So after the photon collects the data, it does runs an analysis on it and sends that data to the photon or the Raspberry Pi. The Raspberry Pi collects data from the photon, and Keith's got it doing some additional running it through another program through Python and getting it to display through there also, which is going to be a lot better. One of the problems I want to go over is the voltage. The voltage collection was really difficult for us because we're using this device and we were having a hard time calculating our power factor. We couldn't figure out why. So finally, we were able to get it on an oscope that we could get the straight out of the wall into the oscope and compare the two. So we've got our yellow is coming out of the wall, the blue is what's coming through our device, and you can see how the voltage angle between the two is pretty substantial. As electrical engineering students, we know that the power is dependent on the angle between the voltage and current, so that was skewing our results by quite a bit. So that does it for me. I'm going to turn it over to Keith, who's going to go over the FFT and a lot of the programming portion of the project. So thank you.
All right, thanks, Brandon. Hey everyone, Keith here, and I'm here to give you an update on our prototype and how it's working. In our last progress report video, our prototype had all of the current signature analysis taking place on the Arduino itself. What we were running into was the memory limitations on the microcontroller. When we tried to take a lot of samples, do the FFT, save a signature for each appliance, we were running out of space. So as Brandon discussed, what we're looking at now is sending the raw data over to a Raspberry Pi to have Python do the analysis. So I'll show you what we have here. This is just mirroring the screen on the Raspberry Pi, which is out by the breaker panel. But here on the right, we have just the RMS current for each phase on the house. Samples, collecting 512 samples here, doing an FFT using the NumPy library in Python. So what we'll do first is turn on the toaster, which is a 120 volt appliance. Immediately you'll see the red current's gone up here. There's a little bit of a lag before the samples come in, but you'll see just one of these will go up, and then the 60 hertz spike on the FFT will go up. There it goes, and then this will come up too. And you see most of the change here was only on that first harmonic. Now, I'll do the microwave now. See, it went up again, same phase. And you'll notice the shape of this wave will change, and then the other subsequent harmonics here will go up instead of just the first one. Here's shape change, and there you see those even numbered harmonics increase. So what we believe is that using the Raspberry Pi will give us a lot more flexibility and a lot more memory so that we can better analyze our signature. Thanks. And we'll go to Eric now to discuss the interface.
Thanks, Keith. Hi guys, I will be presenting a quick update on the budget and user interface. The budgetary goal of this project is to stay below $100 for all of the hardware required. Products similar to what we plan to deliver cost upwards of $300, so our goal is to deliver an easy to follow guide to the DIY community that they can have up and running in a couple of hours for a fraction of the price. So far, we will be well within our budget, with the most expensive item being the Raspberry Pi at about $40. Switching gears to the UI, initially we plan to have a total of 3 user interfaces: a web-based, a mobile, and a local UI in the form of some type of an LCD screen. In order to stay within the budget, we decided to drop the LCD screen. In actuality, it was pretty unnecessary since we just use VNC to access the Raspberry Pi once it's connected to Wi-Fi. Keeping the budget in mind, we've been using free web applications like ThingSpeak and the Particle Cloud to access the data our devices are outputting on both computers and mobile devices. Another option is to make the Raspberry Pi a web server so that it can be accessed from a web browser or to upload to a separate website, but we'll need to be mindful of the budgetary restrictions should we need to pay for any type of web hosting. This is something we plan to iron out during the break. Well, I think that about wraps it up for video 2 for Team 16. It's been a rewarding learning experience so far, and see you next semester. Thanks.